So question 7. Alright, see log 25 over 27? We're going to break that into log 25 minus log 3 base 27. Are we cool with that? What can I say about log 27 base 3? Minus 3. Show it in the calculator if you want. Now, what can I do with the 25? You tell me? 5 squared. And what can I do with the square? Go to the front. What does this question say log 5 base 3 is? What do we get 2a minus 3? Happy days. Log 75. Would everybody agree that log 75 is actually the same thing as 25 multiplied by 3? Everybody okay with that? Would you agree that the 25 has been multiplied by the 3? So how can I separate them? Addition rule for logs. What's log 3 base 3? 1. What do we know log 25 is from earlier? 2a. 2a plus 1. Yep. Alright. Now, I'm going to move on. And I'm going to move on to question 9, I believe. Here it is here. Now, express x in terms of y using common logarithms. So, when you're done with this question, it should be x on its own. First thing I'll do is go and move the 3 over to your side. I'm just going to move the 3 over to your side. Is everybody okay with that? Or the other way around? Yeah? What do we do to both sides? What do we do to both sides? Log them. Okay, what do I do with the power? Got x minus 1 there, what do I want to do with it? Okay, any idea what to do with the x minus 1? We get x minus 1 log 2. And that's log y minus 3. What do you do next? X minus 1 equals log y over 3 divided by log 2. Is that okay? Can anybody tell me the big difference between this and this? What's the big difference? Can you tell me? This one can be expressed as log y minus 3 take away log 2. Everybody see the way there's only one log and 2 brackets? This one can't be. This one is 2 separate functions, okay? So you're not allowed to do that. If you're wondering if you're worried, if you're asking yourself whether you can do it or not, here's what you should do. You should get log 5 over log 2. Now what is log 5 divided by log 2? Anybody? Just put it in the calculator. Really quickly. Log 5 over log 2. There we got 2.3. Now, to test whether you're allowed to do this or not, in an exam, if you were confused and you didn't know whether you're allowed to do it or not, make up 2 numbers you know, get the answer, and then test what would happen if you did fuse them together like that. If you don't get the same answer, you're not allowed to do it. Does that make sense? Do you get the same answer? No. You're not going to get the same answer, I guarantee it. Is that alright? So see the way, if I am unsure whether I'm allowed to merge the 2 of them together or not, you can just make up numbers and test it out. And if it doesn't work, you're not allowed to do it. Right? If they were equal to each other, what would happen? It'd mean you'd be allowed to make that move if you wanted. Okay. Now finally, what's left then, guys? What do we do with the 1? Log y minus 3 over log 2. Take away, plus 1. And what's part 2 want from us? Put in y equals 8, and when you put in y equals 8, what do you need then? when you put in y equals 8, you want the answer to 4 decimal places apparently. Right, let's put all that into the calculator then. It's going to be log 5 divided by log 2. And it's going to be add on 1 at the end. We got 3.3219. Anybody else get that? Yeah, thanks. We good? Alright. Next part. Somebody wanted 11 or something, was it? Where's 11? Next page, is it? 11. Alright. 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 Have to show that P plus Q equals 2R. Now, first of all, we're going to do P, which is log base A 21 over 4. Everybody got that? Next one. Plus log A 7 over 3 equals 2 times log A 7 over 2. Let's do the multiplication rule. Multiply 21 over 4 by 7 over 3. Anybody? Did you get 147 over 12? 49 over 4? Now, no coincidence there. What you notice about those two numbers? 49 and 4. Huh? Squared numbers. So what can we take out? 7 over 2 squared. Everybody cool with that? What can I do with the 2? Bring it to the front. And what do we get? And I just have to prove them that both sides equal each other, haven't they? Okay. That wasn't too bad. Yes. No, 7 over 2 is not allowed near the front because it's not the power. Here. No, you bring the 2 in and square it out. What are you saying? What do you want to do?
Like if you bring the 7 over 2 get above.
You're not allowed to bring the 7 over 2 into the front. You're only allowed to bring the power into the front. So what you're saying is this. If I have log 3, are you saying just bring the 3 to the front? So by your logic, log 3 equals 3 log, is it a 0 or a 1 you leave behind? I suppose it would be 1. And no, they're not the same thing. You're only allowed to bring the power to the front. Okay? Not the actual base number. Yes? Could have, yeah? Yeah, do one step on the right and then one less step on the left. Yeah, same deal, same result. Alex? Now, what am I doing next? What have I done so far? 7, 9, 11. Alright, we're happy with 14 and 15, were we? Alright, now, I haven't done any change of bases with you yet, so that's what I need to target next. I need to do a change of base rule, okay? So 14 was easy enough, no bother. Oh, I have to do 12. Did I give you 12 for homework? I'm going to see 12. Which ones? All of them or? All of them. Alright, great. Thanks. Now, what am I going to do with the first one? I'm going to separate them out. Am I allowed to do this? I divided out the multiply into the addition law. What do I do next then with the 2? Bring it to the front. Why did I bring the 2 to the front? Why? What can I say log x base a is and log y base a? Everybody happy with that? Would everybody agree this time I have 3 individual parts? I have a a, I have an x, and I have a y. Everybody see that? The way it's ax, y. So what can I do here? Log a base a plus log x base a plus log y base a. Why am I allowed to do that? I can just multiply them all back out by each other, can't I? And I'll get ax, y. So what's the answer here? That's 1, that's 4, and that's 5. The whole thing is 10. You good? Alright. Now, next one. Bit more difficult. What can I do with this rule here? What can I break it up into? Again, into division, isn't it? Okay. Anybody got the next step for me? What do I want to do with that root x? Power of a half, thank you. Charlie, what do I do with the half then? Power, so what am I able to do with it? Bring it to the front. Now what do I do? Ax is 4, yeah. Minus 5. 2 take away 5 is minus 3. Right, pause it there. Alright, change of base law works like this, lads. If I have log 10 base 2. Everybody okay with that? 10 base 2. I'm allowed to change it into anything I want, any base I want, provided what? I do what? Provided it's 10 on the bottom and, 10 on the top and 2 on the bottom. Does that make sense? Alright, pick any number you want, doesn't matter. Once it's the same number, twice. Does that make sense? Any number you want, once it's the same number, twice. Can anybody tell me, what can I do with log 25 then? Sorry, gents. What can I do with log 25, x base 25? Okay, think about it. I can change that into log x over log 25. What base number should I pick? I'm looking to figure out what base number I should pick. Why am I picking 5? It's in the question over the other side. It's a good choice. Now here's the easy part. What's log 25 base 5? 2. And what's that divided by 2? I have log x base 5. Is that right? Alright. 7, 9, 11, 12, 13. Let's move on. Now, 7, 9, 11, 12, 13. Alrighty. Now, these ones are terrible. I've seen them in the solutions, okay? And they use the calculator anyway. So guess what they do in the solutions? And it doesn't make any sense. Is that they actually convert them to the same base number. Makes absolutely 0 sense. So here's what they do in the solutions, right? I'll explain why it's a waste of time. So questions 16 and 17 are essentially a waste of time, and I'll explain why. So, log 15, guess what they turn 15 into? They turn it into 5 by, see that? Then they turn it into log 5 base 3 and minus log 3 base 3, and you still have your log base 2 there, don't you? Okay. And then they turn that into 1, and then you're left with log 5 base 3 and take away log 2 base 5. Why are the two logs incompatible? Why is there no compatibility between the two of them? Huh? They're not the same base, are they? So then what it does in its infinite wisdom is it decides to use log 5. So I'm going to change it into log 5 over log 3. Everybody cool with that? And change this one into log 5 over log 2. And then it decides to put a 5 in here. Okay? So I get 1 over log 3 base 5. Take away 1, take away 1 over. Now, why is this a colossal waste of time? I'm going to have to use the calculator anyway. Therefore, why didn't I just do it at the very beginning? I didn't design the book or the solutions, okay? So here's what you do. Just lob it into the calculator at the very beginning. Why waste your time? Is there any indication that you have to do anything different? No. 16 is a calculator question. 17 is a calculator question. Now, with 17, there is a chance that you could put it as a base 3. How do I know I could put them both as base 3? Anybody? Because 27 and 81 both have the same. 3 will multiply into both of them, won't they? So how many 3's make 81? 4. How many 3's make 27? 3. So the answer would be 4 over 3. You can use your calculator straight away again. For practice sake, can everybody do 17 part 2? Well, I want you to change the base number into 2. Okay? And try and do it without the calculator. Okay? If you can do 17 part 2 without the calculator, that's good. Question 16 needs the calculator. Question 17 doesn't. Okay? Alright. Now, on artist. Now, log 8 base 2, log 32 base 2. How many 2's do you need to 2 multiplied by 2 multiplied by 2? Which would be 3 of them. 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2 is 5 of them. And then your answer would be 3 over 5. For our case, now, to be honest, if you just threw it into the calculator straight away, you'd still get 3 over 5. And there's no indication in the question I have to do anything different. Now, here's something you need to know. Anybody have any idea how you might do this one? How do you turn log b base a into log 1 over log b base a? So a base b turns into b base a. We're going to do the change of base form. That's the first thing you're going to do. You're definitely going to do the change of base. So which one's on top? Which one's on the bottom? Any indication of what base you're going to use? How do you know you're going to use that? It's in the answer, isn't it? And this is really easy. What's log a base a? Yep. And you just had to prove it, haven't you? That's a handy thing to know, but it's not necessarily in your tables. Yes?
How do you know when to use the base?
The question will have different bases. So they won't all be the same base number. Every question you did earlier in the chapter, see the way they're all, let's see if we go a bit further back. Base 3, base 3, base 3. No need to change the bases. If this is a later on question, it'll be base 3, then base 7 or something like that. And then you might have to change them. That make sense? Okay. Now, we need to get our speed on here. Oh, lovely question. Alright. Here's what I want from you guys. Right. What is log daily to the base Kenny? 1 divided by, anybody? Log, come on. Log Kenny base daily. Using that knowledge, here's what I want from you. I want us to do that rule on all three of these, the green parts. I want you to flip them back upside down again, and it should work out nicely. Give it a go. And you need to flip the other side as well. Okay? Give it a go, using that rule there. 1 over log x base 2 is actually the same thing as log 2 base x. Next one, log 3 base x. One after that, log 5 base x. And then the last one. Alright? And finally, what's 2 multiplied by 3 multiplied by 5? There you go. Proved they're equal, haven't I? That turned out to be pretty handy. Alright. Now, 19 is done. Next page, I suppose. 11, 12, 13, 16, 17, 19. Alright. Now, alrighty. Can anybody do, I'll do 21, right? So guys, what's the problem with 21? Different bases, okay? So the bases is an issue. Now you have a choice. You can choose base 9 or base 3 to change. You're going to change one of them into the other one. I tend to stick with the smaller number. That's my general rule. Everybody remember that off? If you can, stick with the smaller number. It works better, usually. Okay? So what do I mean by that? I'm going to keep log a base 3 the same. But what I'm going to do to this one? I'm going to change it into log a over log 9. And what base am I going to use? 3. How many 3's make a 9? Log 9 base 3 is 2. Everybody cool with that? So what's it going to be then? It's going to be log 3 base a plus log, a base 3, sorry my fault, over 2 equals 3 over 4. We cool with that? Common denominator of 4. Everybody cool with that? So what's 4 plus 2 of them? How many is that? 6 of them. 6 log 3 base a equals 3. And what's 3 divided by 6? Huh? 2? No, not 2, a half. So 3 divided by 6 is? 3 divided by 6 is a half, yeah? Shouldn't have to too much. Alright. How do we get a on its own? Any idea? A equals 3 to the power of a half. For those of you that memory is a bit sketchy, green position always equals yellow position to the power of blue. Everybody got that? Green is always equal to yellow to the power of blue. Every time. Okay? Doesn't matter what's there. Alright, let's get a bit further up here. We're going to go after some of the latter ones now. Some things with a bit of beef to them. In question 23, you see the way it says, see in question 22, see the way it's ln. There's an ln button. It just means it's just another log. And you can just use your calculator, can't you? No big deal. Lovely. Now we're in business. Alright. Look at this, guys. 27. And I suppose I could probably do 26. I'll try 27 first. Alright, lads, any idea to do 27? Look at the left side. What do you see on the left side? What type of rule? Multiplication rule. What's this 17 minus 3x multiplied by x? 17 minus, 17x minus 3x squared, yeah. Next step, I did it a second ago. 17x minus 3x squared on its own is equal to what? Anybody? 10 to the power of 1. The base number went up. Then you get 3x squared minus 17x plus 10 equals 0. You're not allowed to have a negative log, so what does that mean? Any negative x values will be disqualified. Enter in log any minus number into your calculator and you'll get undefined. Log minus anything. Not errors. Okay? Alright. Now. Yes.
I put one become.
Okay. Green part always becomes yellow part to the power of blue part. So do you get that? It moves around in the same way. Okay. Now, what are the two numbers we're going to put here, lads? What do you reckon? 5 and 2? So, x equals 2 over 3 or x equals 5. Happy days. Everybody cool with that? Alright, is there anything beyond that? Oh dear. Oh, 2 minutes. Alright, hell with it. Question 30. I should get this done in 2 minutes. I hope. Alright, so question 30, guys. Looks like this. Alright. If log x base 6 and log y base 6 equals 1, show that x equals 6 over y. No bother. The multiplication rule. This means log 6, multiply the x by the y, and you get xy equals 1. Bring the 6 upwards, you get xy equals 6 to the power 1, otherwise known as xy equals 6. Everybody cool with that? Let's look at the next part then. What can we change that to? We just did it up here. What can we change that to? Huh? We can change it into xy equals 1 and then 5x plus y equals 17. Do you guys know how to finish that off? You get y on its own. And when you get y on its own, what do you do then? Plug it in and finish. Alright, you guys are going to do... You guys are going to do 23, 25, 28. You're going to do 30. You're going to try 31. You're also going to do 18, 20, and 21. Thanks.